Assalamu alaikum, dear students. Hope you are well. Today I will discuss chapter 6 geometrical optics. In my last lecture I will discuss prism and the equation of prism. The part of prism is finished. Today I will start lens, the second part of this chapter. Then first come what is lens. You know what is lens, you read in class 9 and 10. Lens, any transparent refractive medium bounded by two spherical surfaces or one spherical and one plane surfaces, then we call the plane surface is lens. What is lens? Any transparent refractive medium bounded by two spherical surfaces or one spherical and one plane surface is called lens. There are two types of lens. Number one, convex or converging lens. Then number two, concave or diverging lens. Convex or converging lens and concave or diverging lens. These two types lens we discussed. What is convex or converging lens? The lens whose mid portion is thick but the edges are thin are called the convex or converging lens. Convex or converging lens is the lens whose mid portion is thick but the edges are thin. Then this lens is called the convex or converging lens. In figure number A is convex or converging lens. This lens generally converges a beam of rays at a point, so it is called converging lens. Then number 2, concave or diverging lens. Concave or diverging lens is the lens whose mid portion is thin but the edges are thick are called the concave or diverging lens. The lens whose mid portion is thin but the edges are thick are called concave or diverging lens. In figure B is the concave or diverging lens. Here the lens generally diverges a beam of rays, so this is called concave or diverging lens. In these two lenses, we know some definitions of first and second surfaces of a lens, then center of curvature, radius of curvature, principal axis and principal focus. Most important definition of lens, and you should know it. First we come to first and second surfaces of the lens. First and second surfaces of the lens are: first and second surfaces, the surfaces on which the ray of light is incident on the face through which the ray of light enters a lens is called the first surfaces of the lens. That means the surface in which the light of rays incident, which the ray of light enters a lens is called first surface of the lens. Second surface of the lens, the surface through which the ray of light emerges out of the lens is called second surface of the lens. So what is first surface of the lens? First surface of the lens, the surface on which the ray of light is incident on the face through which the ray of light enters a lens is called first surface of the lens. What is second surface of the lens? The surface through which the ray of light emerges out of the lens is called second surface of the lens. Then we come to the definition of center of curvature. What is center of curvature? Center of curvature is, from the definition of lens, it is seen that each surface of a lens is a part of a sphere. So lens has two center of curvature. How many center of curvature of a lens? Lens has two center of curvature. The center of two spheres of which the surface of the lens is a part is called the center of curvature of that surface. In figure, C1 and C2 are the center of curvature. Again see that center of curvature. What is center of curvature? The center of two spheres of which the surface of the lens is a part is called the center of curvature of that surface. In figure, C1 and C2 are the center of curvature. Then radius of curvature. What is radius of curvature? we know that lens has two radii of curvature. The radius of the sphere of which the surface of the lens is a part is the radius of curvature E of that surface. Lens has two radii of curvature. The radius of the sphere of which the surface of the lens is a part is the radius of curvature of that surface. In figure, R1 and R2 are the first and second radii of curvature of the lens. In figure, you see both of two figure, R1 and R2 are the first and second radii of curvature of the lens. Then principal axis. What is principal axis? The straight line passing through the center of curvature of both the surfaces is called the principal axis of the lens. What is principal axis? The straight line passing through the center of curvature of both the surfaces is called the principal axis of the lens. Most important thing of lens is principal focus. What is principal focus? Lens has two principal focus. Number one, first principal focus and second principal focus. First principal focus and second principal focus. First principal focus. The beam of rays of light emerging from a point on the principal axis or directed towards a point on the principal axis after refraction become parallel to the principal axis. That point is called the first principal axis in figure, which is capital F. Principal axis is denoted by capital F. The beam of rays of light emerging from a point on the principal axis or directed towards a point on the principal axis after refraction become parallel to the principal axis. That point is called the first principal focus, which is denoted by capital F in figure A and figure 2, both figure. Then we come to the what is second principal axis. Second principal focus. Second principal focus is beam of light rays parallel to the principal axis after refraction meet at the point at the principal axis or appear to emerge from the point on the principal axis. That point is called the second principal focus, which is also denoted by F. Then focal length. What is focal length? What is focal length, which is denoted by small f? What is focal length? The distance from the optical center to the principal focus is called the focal length. The distance from the optical center to the principal focus is called the focal length, which is denoted by small f. Principal focus is denoted by capital F and focal length is denoted by small f. Principal focus is denoted by capital F and focal length is denoted by small f. These definitions are most important. Optical center. Which is optical center? A ray of light is incident on the one surface of a lens emerges in such a way that the emergent ray is parallel to the incident ray. Then the point on the principal axis through which the ray of light passes is called the optical center. Which is optical center? A ray of light is incident on the surface of a lens emerges in such a way that the emergent ray is parallel to the incident ray. Then the point on the principal axis through which the ray of light passes is called the optical center. These definitions are most important to know the lens image, to create an image of the lens, which we discuss in our next class. Then most important equation of the lens, most important. Refraction of spherical surfaces, most important. Refraction of spherical surfaces. How refraction on spherical surfaces? In figure, you see that a concave spherical surface SOS prime has separated air and a medium of refractive index mu. A concave A concave spherical surface SOS prime has separated air and a medium of refractive index mu. You know that refractive index of air is 1. We also know refractive index of air is 1. So one medium is air and another medium which refractive index is mu. The refractive index of the right hand side medium air which is 1 and the left hand side of the medium is mu. Let mu is greater than 1. C is the center of curvature. In the figure, C is the center of curvature and O is the pole of the spherical surface. C is the center of curvature and O is the pole of the spherical surface. P is a point source situated on the principal axis in the air medium. P, which is a source, point source situated on the principal axis in the air medium. A light ray emerging from point P and coming along PO falls perpendicularly on the concave surface and thus after refraction goes along the straight line OR. Again I told you that a light ray emerging from P and coming along PO falls perpendicularly on the concave surface and thus after refraction goes along the straight line OR. Another ray PS which falls on S very near to the pole. Another ray PS which falls on S very near to the pole. After refraction bends towards the normal CSN and goes along ASA. These two refractive rays are mutually diverging. If the rays are extended backwards, it seems that they are diverging from the point Q. Thus, Q is the virtual image of the point P. So, there will be create a virtual image which is Q. A virtual image is Q of the point P. Two refracted rays which are extended backwards then meet up a point Q. So, Q is the virtual point of P. Then we come to a equation. Angle of incidence in the figure. Which is the angle of incidence? The angle of incidence is angle PSC equals to I and angle of refraction angle NSA equals to R. Angle of incidence cone PSC and angle of refraction angle NSA. Now from the second law of refraction, we know that refractive index of the medium mu equals to sine I divided by sine R. So we write sine I equals to mu sine R. Sine I equals to mu sine R. As I and R very small, so we can write sine I equals to I and sine R equals to R. Then the equation become I equals to mu R, which we denoted by number 1 equation. Number 1 equation is I equals to mu R. In figure we see let angle SPO equals to alpha, angle SQO equals to beta and SCO equals to gamma. Again see angle SPO equals to alpha, angle SQO equals to beta, angle SCO equals to gamma. From the triangle SCP, we write that gamma equals to I plus alpha. We know the external angle of a triangle is equal to the sum of the two opposite internal angles. The external angle of a triangle is equal to the sum of the two opposite internal angles. So, the external angle of the triangle ACP equals to gamma and opposite two internal angles are I and alpha. So, we write gamma equals to I plus alpha. In the equation, we need I. So, from this I equals to gamma minus alpha. Again, from the triangle ACQ, in the same formula, we write that gamma equals to R plus beta. Here we need R, so R equals to gamma minus beta. Now we find I and R. So we put I and the value of I and R in figure A. Then we write gamma minus alpha equals to mu into gamma minus beta, or gamma minus alpha equals to mu gamma minus mu beta multiply with gamma, then mu beta minus alpha equals to mu gamma minus gamma. Mu beta minus gamma, we can common gamma mu minus 1 into gamma. Rewrite from the equation. Now considering the real positive sign convention. Real positive sign convention, that is all real distances from the pole of the spherical surface are positive. All real distance from the pole of the spherical surface are positive and virtual distances are negative. All real distance of the pole of the spherical lenses are positive and virtual distances are negative. So which is positive, which is real distance and which is virtual distance? From the equation we see that last equation, from the last equation, mu beta minus alpha equals to mu minus 1 gamma. Then we write, as the aperture of the spherical surface is very small, alpha, beta, gamma angles also will be very small. Alpha, beta and gamma also will be very small. If the angle are expressed in radian, we expressed the angle in radian, so we get mu into SO divided by SQ minus SO divided by OP equals to mu minus 1 SO divided by OC. Again, see it carefully, mu into SO, alpha, beta, gamma, these angles are expressed in radian. So we write mu into SO divided by SQ minus SO divided by OP equals to mu minus 1 SO divided by OC. Then we divide both sides by SO, then we get mu divided by SQ minus 1 divided by OP equals to mu minus 1 divided by OC. Then we consider all real distances from the pole of the spherical surface are positive and virtual distances are negative. Then object distance OP equals to plus U, image distance OQ equals to minus V, and radius of curvature OC equals to minus R. Putting these values of equation, then we get mu divided by minus V plus minus 1 by U equals to mu minus 1 divided by minus R. We rewrite the equation, then we get mu by V plus 1 by U equals to mu minus 1 divided by R. The same relation is found for spherical convex lens. This is the equation. This is the equation which we found the spherical surface, refraction at spherical surface. Most important equation. Here we air medium and another medium. Air medium refractive index in 1 and another medium refractive index is mu. But if we have two medium, mu1 and mu2, then the equation will be mu2 divided by V plus mu1 divided by U equals to mu2 minus mu1 divided by R. This equation will be used two refractive index medium where mu1 and mu2. If the refractive index of one medium is mu1 and the refractive index of the other medium is mu2, then we write this equation mu2 divided by V plus mu1 divided by U equals to mu2 minus 1 divided by R. But if one medium is air which refractive index is 1 and the another medium is refractive index is mu, then we write the equation mu divided by V plus 1 by U equals to mu minus 1 divided by R. You should be very careful about this. What is the two medium? If air, then refractive index is 1, so we write the equation mu by V plus 1 by U equals to mu minus 1 divided by R. But if the two medium is refractive index mu1 and mu2, here no air medium, then we write the equation mu2 divided by V plus mu1 divided by U equals to mu2 minus mu1 divided by R. Here V is image distance, U is object distance and R is radius of curvature. Mu1 and mu2 refractive index of two medium. So Hope you understand these topics. Refraction of spherical surfaces. Stay well and read properly. Okay, thank you. Allah Hafiz.